Welcome to the first lesson on processing. This is being recorded as part of the BCIT Technology Teacher Education TTED 5060 course as we make our transition to online learning. Processing is an excellent programming language. It's available on multiple platforms, Mac and PC, and you can even run it on your Android or iOS device by downloading the appropriate apps. I've really liked it because it uses an interface very similar to the Arduino programming interface, and a lot of the code structure is very similar to the Arduino, except it allows you to use all of the power of a full-on computer. All right, so one of the things that I want you to do is open up your web browser and go to processing.org, www.processing.org, and that will take you to the home page for processing. And this is where you're going to find all of the information that you need in order to run processing. All of your help and reference files are listed right down here. And in this lesson, we're going to take a look at some of the introductory tutorials so you can get a feel for the user interface in processing. So now that you've come to processing.org, pause me if you need to go and get your browser set up. I want you to come to the download link. And this should be pretty straightforward. If you go to download, you can go ahead and download the operating system that you're using. I'm on a Windows 64-bit system, and so I'm going to download the Windows 64-bit version. And there we go. I'm downloaded, and I'm opening Windows processing.zip. Okay, so we'll go ahead and we'll open that up. And now I've got a file right here. Now, it's going to download as a compressed folder, so we're going to have to extract that compressed folder before we can use it. And the easiest way to extract that compressed folder is just to click on it right in here and drag it right onto your desktop. So compressed folders are really neat. They let you store gigantic conglomerations of files, and the compression algorithm goes through and removes any unnecessary data and compacts it up into a much tinier file format. It just takes a little while to do the compression and a little bit of time to do the decompression. So right now we're decompressing that file, and here we go. This is exciting to watch. Depending on the speed of your processor, it might take a little bit longer, might take a little bit less time, but as you can see, it's a fairly big file and we're almost done. There we go. So now I've taken this compressed file, which is quite a small file, and exploded into something a little bit bigger. I can close this window now, and I've got a folder on my desktop called Processing. The current version of Processing is 3.5.4. Processing is really cool in that you don't need to install it, so you just need to download it, and then you can run it directly from inside the processing folder. So you can open the processing folder like that, and you'll see a program in here called processing.exe. This is handy if you're working in a school or lab environment where you don't have permissions to install software, because you don't need to alter the registry inside the computer. You shouldn't need to get IT support in order to run processing on the computer. One problem I did run into the first time I installed processing on my system was that Windows tried to tell me that there was some kind of virus attached to it. I can assure you that if you've downloaded the site from downloaded the program from the processing.org site, that you've got a good program. These people have been publishing processing for years, and they're a collection of open source developers. You'll be just fine. Double clicking on processing right here, and you'll see this window popped up. Excellent. So if you get this, you can just tap on more info, and you can click on Run It Anyway. I don't normally recommend doing this unless you know for sure that this is good software. All Windows is saying is that, hey, I don't know that this is good software, and you've got my assurance that if you download it from processing.org, it's good software. You should only see that message the first time you download it, or the first time you run it. Okay, so the processing window pops up right here. I'm just going to close this window from the background. I don't need it anymore. And that's going to let me take the processing window and make it go a little bit bigger on here. And so you'll see processing has a lot in common with the Arduino interface. So those of you who've used Arduinos before should be fairly comfortable using this. We've got our run button up here, a stop button up here. We've got some space down here for error messages. And in the middle is where we'll put our code, or sketch as we like to call it in the processing and Arduino languages. I don't know why they call it a sketch instead of a program. I think they're trying to make it sound easy and user-friendly. It's programming, damn it. It's not supposed to be easy. All right, let's take a look at one of the first things that we can do with this. We're just going to type in a command. We're going to say ellipse. Okay, now, as soon as I start doing that, look at this little line down at the bottom right here. This is something I wish they had in the Arduino interface. You can see right here that it immediately recognizes that we've typed in an ellipse function, and it tells us what information we're supposed to put in here. Float, of course, referring to the type of variable that goes into each space. So what we've got is we've got some X and Y coordinates on here, and we can go ahead and we can type in our X and Y coordinates. Let's go 100, 100, 50, 50. And again, follow that red line. It's giving you hints, just like you had someone looking over your shoulder who knew how to do the programming. It says missing a semicolon. Put that semicolon in there, and you can go ahead and click Run. And a program window pops up right here. And there we go. We've got an ellipse drawn at the 100, 100 mark, and the radius is 50, 50. So it's a circle, right like so. You can close that. Let's try this and make it a little different. Let's put that circle right in the middle. Let's go 50, 50, 50, 50. So our X and Y coordinates are 50, 50. And let's go ahead and run that. And now we've got a circle right in the middle of the screen. Now, this is actually covered in the first tutorial of the processing website. So if you come back to the processing website and go to the tutorials section, you'll see they've got some video tutorials. Excellent to look through, but they're not going to guide you step by step on how to use the software. The Getting Started tutorial is an excellent one that I want you to work through step by step. So let's take a look at the Getting Started tutorial right here. And as we do it, I'll give you a bit more information on things that you might not immediately get as you work through the tutorial. If you're feeling confident and feeling comfortable, you can pause this video right now or fast forward through everything that I'm doing and just follow this tutorial. It's really well laid out, but I'm just going to walk through, and while I won't read the information to you, I will point out some things that are useful and might not be immediately obvious. Okay, so they've done pretty much what we've done. They've downloaded the software, they've got it installed, they've got this window up and running. And to test to make sure it was working, they did the same thing that we did. It's almost like I'd read this tutorial before, a few years ago, in fact. Okay, so here's a description of exactly what they were doing. And that worked great. It executed one command once, and then the program came to a stop. There was nothing else going on there. The computer did exactly what we wanted it to do. If we want it to do that more than once, we need to create a new program structure. Okay, and right down here, we can go Setup, and let's copy this program and come over to our processing window, delete where we had ellipse in there, and paste their code in right now. And if you paste that code in right now and run that code, now you'll see that your mouse interacts with the screen, and when your mouse passes over the screen, it draws ellipses onto the screen. So you can go in there and you can doodle around and you can, right. I'm going to close that window now. You're probably having fun drawing circles on the screen. Let's take a look at some of the structures that are going on in here and why I say it's similar to an Arduino program. In your Arduino program, the first thing we have, well, we have variable declarations that go above that, and we'll talk more about that too, but we have void setup, bracket, bracket. Okay, and again, you don't have to panic about what some of this terminology means. If you're concerned, the quick background is that each of these routines is called a function. And a function has to be able to stand on its own. It usually does two things. It will have variables passed to it, and it will return a variable back from it. So you can think of a function as being like a person who goes out and does a job. You need to give them information on how to do their job, and they need to come back and tell you that the job is done and give you something back when they're done. What void means is that this function is not going to return anything. So it's going to go and do a job, and it's not going to come back and give you any information when it's done. It could give you an information in the form of an integer or a floating point or some type of number. Okay, so we do have other words that we could put in there. Void just means you're getting nothing back. Setup is the special name of this that tells it that it's going to run once at the beginning of the program. Just like setup in your Arduino runs once. And these brackets right here tell it that nothing is being passed to it. So you're not giving it a number. For instance, if you had a function that was said int square brackets int, then what would happen is that you would pass it an integer, it would square that function, and then it would return the squared integer. We're not doing any of that right here. This is just standard setup. There's a reason for it, and as you do more programming, it'll become more understandable why they're doing it. Just like the Arduino or any C-based programming language, the squiggly brackets right here, the ellipses, indicate that everything within there is controlled by that function. So you'll notice that if I put my cursor right next to one of the ellipses, that its matching ellipses is highlighted. You can think of those as hugging that section of code. It wraps it all together and says, okay, everything between here and here is controlled by the setup routine. We'll use these for other functions, our if statements, for instance. This one right here creates a hug that matches to this one right here. So everything underneath here is covered by the if statement, and everything down here is covered by the fill statement. You'll notice that to make this easier to read, things have been indented. So everything controlled by setup is indented one tab from the setup line. And everything under if is indented one line from the if. So we're using our tabs to align things right in there. And there is usually somewhere in there an auto format function that will help you get the format just right. Alrighty, so let's take a look at what happens when this program runs. It comes in here and it goes void setup. Size is a very important command in the processing language because it tells you the size of the window that you're going to create. Did you notice that we had a wide and narrow window when we ran that code? Let's just run that again and take a look right here. And so the size command tells us this is going to be a window that is 480 pixels wide by 120 pixels high. I'm just going to close that, come back in right here. If we wanted a bigger window, we could go 480. Do not go 4480. Let's 480 by 480. And now we've got a window that is 480 wide by 480 high. And you'll see us use that sequence again for a lot of things that we're going to do when we're talking about your screen. You've got an x-axis that comes first and controls horizontal size or horizontal movement, and a y-axis that comes second and controls vertical size or vertical movement. So just a couple of neat things that you can do right in there with the mouse right now. Cool. Let's flip back to the tutorial and follow it through in a little bit more detail. Okay, it talks about some aspects of the user interface and how to save your files and where your files are being saved. Okay, your programs are going to be saved to something called a sketchbook, and right now it's probably a good idea to come in here and just take a look and go File and Preferences and take a note where your sketchbook is, because when you press Save, that's where your files are going to be saved. You can change it to something else if you don't want to save it to D, or if you're on a network computer and D drive is locked down, you could change this to be your flash drive or something like that. But you should know where that sketchbook location is. Alrighty. So there's some other neat things that you can do in here, and I'm going to skip over some of this but come back to it later. One of the cool things about processing is that when you are done with your file, you can actually export this application as a working Windows exe file, and you can share that with somebody who doesn't have processing installed on their system, and it'll run just like any other program. So if you wanted to have somebody be able to use what you've just made right there, you could export the application, you could email it to them and say, hey, look at this, I made this cool program. All right, and now in here it talks about the examples in the reference section, and this has some examples which are a little bit advanced for some of the stuff that beginning programmers will want to get at, but you can learn so much from looking at them when you're ready to look at them. We're going to do a few simpler things first. So that just walks you through the basics of the user interface and lets you make sure that everything's working. Okay, now if you weren't able to draw the mouse and you weren't able to keep up to this point, there's something going on your computer. You need to stop now and get that sorted out, because things are going to get interesting pretty soon. All right, let's come back to that tutorial section. You can hit the back arrow or just click on tutorials again. And let's take a look at the processing overview tutorial. Now, this is a little bit more detailed. So again, you can go through and do a quick read of it, but I'm going to pull out some of the highlights right in here. Okay, and let's take a look right here. You'll see it refer to a Hello World program. Hello World in any programming language is what you do to get it up and started and running and demonstrate that it works. So for instance, if you're familiar with Arduinos, the Blink program in Arduino would be the Arduino equivalent of Hello World. Here, they say it's drawing a line. We drew an ellipse. Same difference. You're just doing something to show that it works. This starts showing you some of the different commands that are going on right in here. And one of the things that you will see when they're writing their code in here is that they'll make reference to hexadecimal numbers, assuming that you know what they're talking about. If you haven't studied hexadecimal numbers before, it's a really neat counting system where it's done on base 16. So instead of the number 10, we use the letter A, and B for 11, C for 12, and F for 15. And what that lets us do is that it lets us express 1 byte of information the values from 0 to 255 in just 2 characters, which lets you keep things aligned neatly and also makes it easier for you to map out the shorthand value right here into a binary value. And that matters a lot later on. Don't get too excited about it. If you're wondering, what the heck does it mean? Hashtag FF8000. That is actually a number. It's just written in a numbering format that you may or may not be familiar with. Okay, so it goes through and it does some more of the things that we've just done. And we've got in here, we've got a new command in here for the background. So if you want to try some of this code, just come in here, delete everything that you've got right there. You didn't spend a lot of time typing it, and you can always find it again in the previous tutorial. And let's go ahead and let's take a look at this program right here, and just copy that and paste it. And let's go ahead and run that code. Ooh, what just happened? I pushed the mouse button and it got me a new screen with a new background color. Okay, interesting. We've got mouse interactivity, we've got mouse button interactivity, and we've got some graphics being drawn on here. Maybe not gonna have to worry about your subscription to a Photoshop being replaced anytime soon. Let's go ahead and close that and take a look at some of the things that are going on right in here. Now, we've got 3 functions happening right in here. We've got void setup. We've got our window size. Okay, a critical aspect of any processing program because it is going to interact with the screen. So you need to tell it how many pixels to allocate in terms of screen space. We've got stroke, the thickness of the line that we want to draw, or sorry, the color of the line that we want to draw. You'll find the information right over here. If you ever see a command like that that you're unfamiliar with and you want to know more about it, okay, you can either click on help and go to the reference. Okay, very useful tool. Let's just pop that up. And here's your language reference, just pops right up over here for you. And you can come and type in stroke. What was stroke doing? There we go. No, you might be at this point at some point, but hopefully not. Let's take this on, the stroke in the processing language right here. And you'll find helpful information on what stroke does all the way through right here. Stroke sets the color used to draw the lines and borders around shapes. Okay, let's go back to our tutorial over here. And so what was happening right in here is we can see that we set that line color. We come down here to draw. Our draw is just like void loop in the Arduino. It's the part of the program that's going to keep repeating over and over and over and over again. This is where the program is actually running. And you can see the location that where our line is beginning at. And the location our line is going to is a function called mouse X and mouse Y. So because we use the mouse so much, they have their the location of the mouse has its own special name right in there. So we are drawing a line from this coordinate on the screen in X and Y format to this coordinate on the screen in the X and Y format. Now, there's a third function right in here, and this is called void Mousepressed. And again, void just means nothing's being passed into it. And because there's nothing between these brackets right here, that means that it's not returning a value. And you can think of this value as kind of being like an interrupt function. If it detects the mouse being pressed, it will come down here and it will execute this code right here. So when the mouse is pressed, it comes and does this thing down here. So that means that your program can run normally, and then whenever the mouse is pressed, it says, oh, stop doing that for a second, come do this. Then it pops back here and carries on doing everything right in here. Okay, So there's a few other neat things that we can run in processing. Now, right now, we've just been using the green arrow to do run. Some of the other things that we can do in here is when you take a look at this, well, you can do present, which fills up the entire screen. There we go. So if I wanted to hide all the background screen from it, I could do present, and then I just hit the escape key to get out of that. So good if you kind of want to hide everything else on your screen. But the one that I really like on here is tweak. This is an amazing function. So let's try tweak. Okay. Oh, yes, I need to save the sketch. File, save. And we don't have to worry too much about giving it a fancy name. Go ahead and save it. Anytime you've created something for yourself, not only save it, but save it regularly. The number of times I've wanted to have a backup copy to go to and not been saving things properly has taught me to save regularly. Okay, let's try that again now that it's saved. And sketch, tweak. Okay, and that pops up right in there. Now, our program's running around right here, and you can see it's running just like before. But this line has a little marker next to it, and I can come over here and I can tweak any of these values. So remember how the screen changed to orange when I pressed the mouse button? What if I didn't want orange? What colors could I get? So let's try changing there to right there. Let me come back to our tweaked screen. I'm just going to move it over here so I can see both of them. And now when I push the button, it goes to light orange. And you can play with the value in there. Some form of burnt umber. I'm just clicking and holding and dragging that down. And now I've got different colors in here. So if you just wanted to play around and experiment to find out the impact, let's not go to negative. These are color values, so they should just come down to 0. There I've got some green. Let's take this one down to 0. Oh, notice that little red slash in there? We put a bad value in there. 0 is fine. Notice that's bright green. I bet we can get to a more intense green if I bump that up. Oh, there we go. We went to an illegal value. It stopped us. There's our fully bright green. And if I want it to go all the way down to black, okay, close enough. I'm pretty close to black. So this means that we're just putting colors in a standard red, green, blue format. Bump that up, and now I've got dark red. Bump that up a bit more. I've got a more intense red. If I want to add some green, it's in here. There's some blue. And so every time I press the mouse, that background color changes. Now you'll notice that right now all of our start points have been right up here. We can also come in here and we can change that start point. We're increasing the X right there. So now I've changed my start point, and I can increase my Y and move it over this way. So now I've changed the start point for each of those lines as well. So this allows you some amazing interactivity to test how different variables can help your program go along. It also helps you understand some of the functions that are happening in here. So for instance, you'll notice that as we moved the Y value upwards, our start point moved downwards. Our 0, 0 coordinate for the processing window is right up here. So as we increase the X, values go up this way. And in this case, we go up to a maximum value of 400 pixels because that's how we describe the screen. And this way is our Y. Our values will go up to 400 in this direction. So anytime you're looking at your screen layout, just remember 0, 0 is at the top left, X going horizontally, Y going downwards vertically. Okay, so that's tweak. And no, we don't need to keep those changes at all. We were just playing around in there a little bit. Okay, back to the tutorial. You can read through some more information on this. It talks more about size. You can skip over some of this information about the uh, the fancy features in the size command and the loading and the displaying of data. It's worth knowing about, but if you're just starting out, this is a little bit complex. And as they say, build a church before you build a cathedral. Actually, build a pew before you build a church. Start small. Take your success one little step at a time. So there we go. That's the second tutorial and some of the information in there, and you've accomplished a lot already. Let's go back to our selection of tutorials. This will talk a little bit more about the coordinate system and some of the shapes that we're looking at. And here you can see that they're talking about basic coordinate systems, XY coordinates. So a little flashback to, I don't know, what was that? Maths, grade 7 math. Okay. And here it just compares what we were talking about a moment ago. There we go, 8th grade. It figures 8th grade, you've got your 0, 0 right there. And just on our computer screen, we've set the 0, 0 right here because we're not going to go into any negative axes. And it talks about some of the simple shapes that you can draw and the way that you can enter that information to draw those shapes. So if you're trying to draw a shape and you'd like a little bit more information on how it works, this tutorial is going to be really helpful. And it's got some code in here, and you can just copy and paste that in right there. Copy, delete what you had right in here. Make sure you delete everything, and always make sure that you've copied absolutely everything. Paste that right in there, and there's your own personal little space alien. Now, you can add color commands in here, and so you can change the colors and change the fills, you can change the line thicknesses, and you can play around and create your own little space alien. But you can see that basically it's not much different from a lot of, actually even G code in terms of what you're creating on your screen. Come back to our tutorials, and since I mentioned color, let's take a look at what you can do with color. So this talks a little bit about color theory and how colors are viewed on computer screens. And so, from dark to light, and it talks about why 0 to 255 are such significant values in the computer. If you've been programming the Arduino, you're probably up to speed on all that. And it talks about some of the commands that it uses. We've seen the stroke command already, but also the fill command, so that you can create colors of different you can create shapes with different colors and different outlines. So for instance, you can come down here and you can try this program right here. Come over here, delete our previous code. And so what we're going to do is we're going to set our fill. Okay, the first value is red, so bright red, no green and no blue. We're going to create an ellipse centered at, oh, now I have to remember my command. Is that centered at 2020 or is it radius 6? There we go. It is going to be centered at 20 and 20, and the vertical radius is 16, the horizontal radius is 16. So if the vertical and horizontal radius are both the same, then we're going to have a circle. An ellipse with equivalent major and minor axes is a circle. Here we're going to see a darker red because we're using a lower value. And here we're going to see a pinky pale red because we're getting closer to the white on each of these. Let's take a look right on here. And there is our little window. And I'm just trying to find a place where I can drag that window around. Anyways, it's sitting right there because I was going to say, let's save this. And let's run this in tweak mode. And that pops up right in there. And oh, you'll see that we don't get to tweak very much at all. Tweak doesn't really work on here because we don't have it repeating over and over and over again. If we want to be able to tweak things, we need the program to iterate or carry on doing things. So let's just come back here and let's close that for a second. And let's set it up so we can run it in tweak mode. To do that, we need to set it into a standard format for a program. So the standard format means that we start up here at the top and we need to say void setup brackets brackets ellipses size and choose a window size that seems to work well for you. This is a very small one. Let's go 200 by 200 and put our closing bracket in there. Okay, and there we go. Now that that bracket's in there, and then we'll do void draw. Says missing the right curly bracket. Keep your eye right down here because this gives you a neat little rundown on your errors. Very helpful. And then we can come down to the end of the program right here. Oh, we're still missing that right curly bracket. There we go. We put it in. That error message disappears. The errors function on here before I run this is really cool. So say, for instance, we misspelled ellipse. The function ellipse does not exist. So the syntax error tracking in here is really, really useful and gets rid of some of the hassles that you would have had using the Arduino IDE. There we go. So now that's running. We've got a larger window on here. I'm just going to close that because what I wanted to do was I wanted to save that. And then I'm going to run it in tweak mode. And now you can see all the different values that you can play with in here. So you can come in here and you can take that 16 value for the ellipse and ooh, all of a sudden it becomes fat, narrow. A couple of interesting things you'll notice is that it's always drawing that one behind the other two, and it's always drawing this one in front of the other two. Whoops, I was going to change that right there. There we go. See, that one's always getting drawn in front. Why is this one always being drawn in front? Well, if you look at the sequence that the program runs in, it draws this one first, draws this one second, draws this one third, then it loops around and comes back here and does it all over again. So the last one to be drawn is the one that gets drawn on top. The program's looping around very, very rapidly though, so things are getting redrawn on a pretty regular basis. Why do we get these black lines left behind? Because we never go back and we erase them after we've created them. So when I expand the width that way, okay, there is still, you can see right at the edge, a black line. As I draw that back, if I draw it back really fast, sometimes I'll even be able to leave a little bit of a pink gap behind. What's happening right in there is that the black line is being left behind and is not being erased. We do have ways to erase that and clear that up. We'll talk more about those later on. Okay, cool example of tweak. Oh, if you wanted to play with colors, again, you can come in here and you can play with the colors. Again, don't get into the values outside 0 to 255 or you get that little slash warning sign as you bring it down right in there. You can play around and you can tweak with things to get colors that you happen to like. And no, we don't need to save those changes. We were just tweaking them and playing them around. One of the useful things about following along in the other tutorials as we go through here, and I walk you through them a little bit, is that they also tell you about some of the useful tools that they have to help you choose some of the colors. So you can see from the menu bar, there's Tools and Color Selector. and you'll get this little window that pops up in here. And so if you're looking for a particular color right in here, you can go through and it will give you the RGB values for it. It will give you the hexadecimal value for it. So for instance, if I drag this all the way up here and let's get right up into the very top corner, I get 255 in the red. There you can see the FF for the hexadecimal value for 255. And if I drag it all the way down here, okay, you can see that that value decreases, and you can move it around right in here. By moving this bar up and down, you change the hue. So there's a couple of different ways to represent color, and RGB is a very standard thing that we use because we're used to using red, green, blue LEDs, and if we add a little bit of red, a little bit of green, and a little bit of blue, then we can piece together a color that we want. But you can also express colors in terms of the hue, saturation, and brilliance of the colors. And for many people working in image processing, this is a more natural way to think about colors because what you're doing is you're saying, well, I'm starting with a fundamental hue, and then I'm playing with the saturation and brilliance in here. And you can see that when I move around right in here, the hue stays the same, but the saturation goes up and down, and the brilliance goes up and down in this direction. So but both systems can represent colors. Some of them make sense depending on the device that you're using to display that color. Okay, color selector is worth taking a look at just because it does give you a little bit of background information on hue, saturation, and brilliance versus RGB. And you can see those hexadecimal numbers pop up in there. So they're all linked together and they all basically mean the same thing. They just say it in different ways. Let's close that. Okay, following through on the tutorial, you'll also see it talks about transparency. So transparency is referred to in a lot of image processing as the alpha channel. So we've got a red channel, a green channel, and a blue channel for our three main colors. You can have a fourth channel called the alpha channel for controlling your transparency. And if you've done video editing or photo editing, you may have had a chance to work with alpha channels when you're doing Photoshop work. So it talks more about custom color ranges, and it talks more about hue, saturation, and brilliance. And for people who really get into this, they've got all sorts of different color modes too, because red, green, blue, and HSB are not the only ways to talk about color. Color is a very complex and very, very analyzed thing that we don't really need to get into right now. Let's go back to the tutorials and take a look at one more. So we've been through here and we've taken a look at getting started, the processing overview, the coordinate systems and shapes, and color. We're going to skip the objects one. Now, objects are really cool. They allow you to create a lot of neat features for games and things like that. Feel free to go ahead and look at that tutorial if you want, but we're going to stay away a little bit from the object-oriented programming for now. Let's take a look at how to get the mouse and keyboard working. Okay, so here's our interactivity tutorial. And when you scroll down through this tutorial, it gives you more information about how to read the mouse and how to use some commands that we're familiar with. So for instance, if you're used to using the Arduino, you'll know that println is a command that we use in the Arduino to print a line to our serial monitor. Println also works in processing. Let's delete our previous program and let's copy and paste that little section into here, and let's see what happens when we run this code. Now, you can see that as I move the mouse around inside this window, and you do have to move the mouse into this window, that we've got numbers popping up right down here. And this is popping out our mouse X and our mouse Y coordinates. So if I bring my mouse right up to this corner, you'll see that the numbers get very small because I'm at close to 0, 0. And if I bring my numbers down to this corner, or my mouse down to this corner, you'll see the numbers get close to 100 by 100, meaning that this screen is 100 by 100, and I can track the mouse inside there at any point that I want. Let's close that. So here's some more examples of what they've done with their mouse tracking right in here. And let's scoot down here. Let's try this one. Right in here. And let's run this code. Ooh, that's pretty cool. We've got the balls moving back and forth. Let's take a look at what's happening right in here to make that happen. So in our ellipse command, the first command right in here is our X and our Y axis for that mouse. And this is the two major and minor axis of the mouse. So our radius stays the same in both directions, so we get a circle. And right in here, you can see that we can actually do a couple calculations. The first one just gets the mouse X position. The second one gets X divided by 2. And the third one gets X times 2. So when I come down here and all of my balls start back here, that's because my mouse X is reading pretty close to 0 right now. And as I move it along here, the top one stays right in line with my mouse. The bottom one is half. Oh, I can't go down there and catch it because otherwise everything moves back, is half of that. And the one on the bottom is twice that. So as I move over to this side, the bottom one goes off the screen because it's over here somewhere. And the middle one goes to the exact middle of the screen. Let's see what else they've got down in here. And again, follow on the tutorial because there's a lot of detailed description of what's going on in the tutorial. The mouse button is another neat function right in here. And although we saw a way earlier that we could control features based on a separate function, we can also include a question about, is the mouse pressed? So let's take a look at this program right in here. Try not to include the graphics when I copy that and paste that over to here. And so now you'll see that we've come in here and it says if mouse is pressed. Remember that in our programming languages we have to use equals equals. Okay, equals equals is asking a question. This is saying if question, is the mouse equal to true? And if we use just a single equal, it would still be a legal statement. Notice that it gave us a warning down here. This isn't an error. It's not in red. It's just an orange. And it's just like, hey, you might want to pay attention to the fact that people make this mistake a lot of time. What's going to happen right now is this is going to take the value of true, which is a logical 1. False is a logical 0. It's going to take that 1. It's going to assign that value to mouse pressed. And you can see it's popping up our warning everywhere on there. So remember to say that we want that to be equal equal because that means that we're asking a question. All right, so this one's going to draw. It's going to set the background. So when we draw something, it'll stand out against the background. If the mouse is pressed when it comes to this statement, it's going to fill it with the white color. And if it's not pressed, it will fill it with the black color. And then it will create this rectangle right here. So you can run this code. And when you press the mouse, okay, I'm having too much fun pressing the mouse right now. It's going to change that color. So excellent examples in the tutorial right down here. Now, the keyboard also starts to get to be an interesting input device. And so here's a quick way to take a look at how the keyboard works. Take this code, copy it, drop it into your processing window, get rid of the old code, and here we go. All right. If key pressed equals true, let's try pressing a key. Oh, there we go. I don't know why that wasn't working. I was obviously pressing a wrong key in there somewhere. I hope you had better success and knew how to press a keyboard better than me. Anytime I press a button on the keyboard, it turns from a rectangle into a slash. Let's take a look at what's going on right here. So we've set the size of our window to 100, 100. We've set the stroke weight, which is going to define the number of pixels that go into making the border for each of our objects. We've set that up to 4. Again, if you're not familiar with any of these commands, look them up in the reference, or you may even be able to just highlight them and go Tool, Help, and Find in Reference. There we go. So just highlight a command and then go Find in Reference. So if you want more information on key pressed, just make sure you've only got one command. Help, Find in Reference. There's the key pressed command. So if you need more background information on any of these, you can access them quite easily just by highlighting them and asking it to find it in the reference. And it works really great if you've got both windows open and it flicks back and forth right in there. And so it's going to take a look and it's going to ask, is that key pressed equal to true? If there is a key pressed on the keyboard, it will draw a line. And because that is controlled within these curly brackets, then that's the only thing that will happen. If it's outside, then it'll draw a rectangle right on there. So now the keyboard, obviously when you press it, it can tell you more than just whether a key is pressed. It can also tell you which key is pressed. So let's take a look down here and try this code right in here. Just paste that right over top. Make sure I delete everything else. So again, our setup routine creates a window 100 by 100, tells us that our stroke weight will be at 4. We could change that somewhere else in the program again if we wanted. Creates the background, and then it checks for 2 things right in here. So again, here's our if statement. We've got our our brackets around the outside. So just like any mathematical equation, it does what's inside the brackets first. So it asks the question, is a key pressed right now? So if the key is pressed right now, okay, then that's true. Our logical AND command. So again, if you've forgotten some of your commands, just go ahead and highlight it, go Help, Find in Reference. Oh, maybe I had too many spaces in there and it couldn't find it in the reference. Not popping up in my reference right now. It may just be too simple a thing for them to put in the reference. Sometimes people who've been programming for a long time forget that there's little shorthand things that that we all know and use that for new programmers are pretty easy to forget. So this is just your logical and then it asks this question right here. So if the key really is equal to A and it's being pressed right now, these 2 conditions are true, then it will execute this section. So you should be able to run this. And now if you press any key, nothing happens. But if you press the A key, you have to hold down Shift A. And as long as you hold down Shift A, it translates. Okay, because you need that capital A. Now, if you wanted a small a to do it for you, let's just close that off right there. Okay, what we could do is we could create another condition right here and say, okay, we're going to put, well, let's put our question in right here. So right in here, we could say key equal to, quote, small a. So we follow the same format that they did for the capital A, but what we're going to do right here is we're going to use the two vertical lines, which represent a logical OR statement. And then just to make sure that it does this command first, we put round brackets around that. So now what's going to happen when it comes in to do this analysis, it's going to ask, is the key equal to a small a? If so, that section right in there is going to become true. Is the key equal to a capital A? If it is, then that section is going to become true. Now, only one of those two can be true at a time, but if either of them are true, then the OR statement means that this overall statement right in here is going to be true. And then it can compare that and it can say, well, the key is pressed and one of these two conditions is also true, so that our small a or our capital A will work. Go ahead and run that. And now if I press the small a, it changes. And if I press the capital A, it changes. But if I press any other key, it doesn't change. You could make this work with the R key and a Q key. So now if you had a capital R or a capital Q, it would change. So this is a good way to check the status of the keyboard and gain some keyboard interactivity as well. All right, let's move back to the tutorial, because you're probably saying, well, a lot of programs I use, you hit the space bar or something like that, or you use cursor keys. And so right in here, this tells you a little bit more about using those fancy coded keys. And so you can press up, down, left, right keys, and all sorts of things like that. As we get a little further down, we also get to some very interesting events: mouse pressed, mouse released, mouse moved, mouse dragged. There's all sorts of things that you can do with a mouse in here. So it's worth taking a look at some of those as well. As we scroll down here a little bit, here's an example of how we could use mouse interaction to create some interesting things right here. Let's copy this code. Let's delete this code right here and go through and run this. Okay. Now you can see I'm moving the mouse around right here, but if I click and drag, I get a black one moving around. Okay. So let's follow through a little bit on what's happening right in here. First of all, that was a really small window, so we could change the size right in here to make our windows bigger. No stroke. Remember, sometimes we put a stroke width command in there. We got rid of the stroke, so it just fills it. It doesn't draw that line around the outside. And that stays in place until we change it and put in a stroke command. We come to our draw routine. The draw routine is just like void loop in Arduino. It's going to keep repeating over and over and over. Sets the background to 204, which clears out anything that we drew the last time around. Sets our fill color to 0 and draws a circle right here. Now you'll see drag X and drag Y. Where did that come from? Well, up at the beginning of the program, we created some integers. So this is again, just like your Arduino program. If you're going to create integers or define, make any definitions, you do it before you get to your setup routine. And that creates global variables that can be accessed by any function within the program. As you get into more sophisticated programming and worry about memory utilization and things like that, there's different places where you can declare and define your variables. But for our introductory purposes, we're going to put all of our variables right up here at the beginning. So drag x is a variable. That's a memory place inside the computer where it can store this number. And so when we call an ellipse right here, it goes into that memory location. It takes a look inside the memory, pulls that value, puts it right into the x value there, goes and gets the y values location, pulls it right into here. Same thing down here, x and y. Well, where do those values come from? Is they come from these routines that are happening kind of independently based on an interrupt, based on something, if something is happening. Okay, so what's happening right in here is if the mouse is dragged, drag x equals x, and drag y equals the mouse y. Same thing right in here. This is moving the gray circle or the black circle. You'll notice that this comes back as drag. So when we draw the black circle, it goes into the direction of the mouse dragged function. And when we move the light colored mouse, it goes into the last value from the mouse move function. So kind of neat things going on right in there. And you can play around with that. And again, experiment. So there we go. That one's staying in place because my mouse isn't clicked. This one's moving around because my mouse is clicked. Key events can also make things happen. So we've got key pressed and key released so that you can test things when those events occur. And finally, it takes a little while to talk about how this is all being handled and the order of the events that these happen. And it comes down here and you can take a look at the cursor setup. And what we'll do in here is let's delete this. Highlight. I've been abusing my mouse apparently. It doesn't want to click on these things. And let's try running this one right here. And there, I've got a cursor at the location that changes the type of cursor, whether or not I'm pushing the button, and I've got crosshairs being drawn interactively. Okay, let's take a look right in here and see how it's doing that. Okay, if mouse pressed is equal to true, then the cursor is equal to the hand. If it's not being pressed, then the cursor is equal to cross. You could come in here and you could try changing that into the wait cursor. And these will be standard depending on your operating system. So this is accessing some of the stuff that's built into your computer already. Oh, I've seen that before. There we go. So I've got the hand. There's my wait cursor moving around right in there. As they say right down here, these cursor icons are part of your computer's operating system and will appear differently on different machines. Even within your operating system, you can go in and change some of those things around. So this is our first lesson, a quick, well, just over an hour introduction to some of the neat things that processing can do. And I hope it's got you excited about coming back and doing the second lesson after you've had a chance to get up, stretch your legs, and maybe grab a coffee. So feel free to stop right there. And when we come back, we'll take a look at more cool things that we can do with processing.